Hey guys, today we're going to be learning about writing exponential functions, and just like when we wrote linear equations, we wrote them for multiple different representations. We're also going to do that for exponential functions. So today we're going to learn about writing them from a table, from 2 points, from a graph, and we're also going to go back and actually graph a few of them in detail. So before we begin, because I'm noticing now that from a table tells me to decide if the function is exponential first. That's step 1. So here I'm noticing in this table that as x increases by 1, y is increasing by a factor of 5, or multiplying by 5 to move over each x value. So that's definitely going to be exponential. For a reminder of what linear functions look like, as x is increasing by 1 every time, this is what we've been working with all year, linear equations, so straight lines, this is increasing by 2. And it's adding by 2. So just as a reminder, that equation would be y equals 2x plus 4. We have a slope and a y-intercept. So here we're not going to have a slope. We are going to have a y-intercept though. And my y-intercept is always going to be where it crosses the y-axis. When x is 0, y is going to be that y-intercept. So here you guys see in the middle of the table, that middle point is 0, 10. Therefore, my y-intercept, my a value of my equation, is going to be 10. So I've got a. So a is 10. And b here is going to be the factor, right? So b represents the factor in an exponential equation. So the factor is 5. I'm multiplying by 5 with each increase of 1. Therefore, my equation, because it's in the format of y equals a times b to the power of x, my equation is going to be y equals 10 times 5 to the power of x for this one. So I'm going to do one of these with you, and then I'm going to have you try the other one on your own, and I'll tell you the answer to give you a chance to pause the video and try that. So for this one, I'm noticing as x is increasing by 1 every time. And then down here, if you didn't want to deal with this, you can come over to the whole numbers and say, well, 5 is increasing. At first, you might say, a lot of kids will say, well, that's adding by 10, but then that doesn't work for the rest of the table. So you're looking for something that's happening consistently. So it's not adding by 10, it's multiplying by 3. And I notice that that's happening for every value of y. And you can go backwards the other way too. This way would be dividing by 3, dividing by 3. So here I have my factor of 3. That's going to be my b value. B stands for factor. And my a value is going to be my y-intercept. The a value is going to be when x is 0, y is that a value. So a is 5. So my equation here is y equals 5 times 3 to the power of x. And you can write that with this multiplication symbol, or you can use parentheses. They mean the same thing. So next, why don't you pause the video, try this one on your own, and I'm just going to go ahead and tell you, hopefully it's paused and you're trying it, I'm going to go ahead and tell you that for this one, your equation should be y equals 9 times 3 to the power of x. I have my a value. I'm going up as x increases by 1. Y is multiplying by 3, so I have a growth factor of 3. So now from 2 points. I'm going to do the first one on here, and then we'll do 2 over off to the side a little bigger. So from 2 points, it tells me that I'm going to substitute each point into y equals a times b to the power of x. So I'm going to go ahead over here, like when we started finding slope, we labeled our x and y, I think way back to like October, November. And I'm going to label x and a y, x and a y, and I know I'm going through those 2 points, and I know it's exponential, I'm telling you that. So here I have it written out for you. I know y equals a times b to the power of x. I'm going to plug in those 2 points, and this little hint down here tells you to place the higher power on top. So be careful with that, meaning that I want the higher x value, because x is my power. I want the higher value on top. So I'm going to put this point on top when I substitute it. So I know y is 81. I don't know a, I don't know b, and I know that x, according to my point, is 4. And then my next point that I'm going to use, I'm just going to use 2, 9. I'm going to write it right underneath. So I know y is 9. I don't know a. I don't know b, but I do know that x is 2. So I have 2 equations stacked up. You can kind of think back to elimination when we were solving systems. I have them stacked up and I want to eliminate one variable. So in order to eliminate a variable here, I'm going to divide. When I divide a divided by a, I'm just going to get 1, so it's going to cancel out. So I'm dividing both equations here. 81 divided by 9 leaves me with 9. The a's cancel. And remember back to the beginning of this unit, we were in school for this. Remember back when we divided b to the 4th divided by b squared, we subtracted the exponents. So I'm doing 4 minus 2 here to get b squared. So if I know that b squared is 9, when I do the square root of that, I end up with b is equal to 3. So now I know my b, right? I've got b. I'm all the way down here actually now. So I've got b. Now I need to find a. So I'm going to substitute everything that I know back in. And I'm going to pick one point. I highly suggest choosing the point with the lesser numbers. So 2, 9 over 4, 81. Your life is going to be a lot easier with your calculations down here. So I'm going to plug in everything I know. I know that b is 3. And I told you to choose the lower point. So I know that x is 2 and I know that y is 9. So I'm going to go ahead and plug that into my y equals ab to the power of x. I'm just going to write it out again so you guys can get used to it. So y is 9. A we don't know. We're going to try to figure that out. I know that b is 3 and x is 2. I know that 3 squared is 9. So I'm left with 9 equals a times 9. And now if I have a times 9 to isolate that a, I'm going to do the opposite and I'm going to divide. So I'm left with a is 1. Now I've got what I need. I've got an a, I've got a b. So my equation is going to be y equals 1 times 3 to the power of x. And you can actually just write it like this in its simplest form. So that's the first example. I'm going to do one with you, and then I'm going to go ahead just like we did with the tables up top, and I'll just give you the answer to one. I won't make you listen to me do 2 more of them. So for this one, I'm going to do the one to the top right. And sorry guys. So I have an x, I have a y, and I have an x, and I have a y. You can even do this as well, so you can differentiate between them. I'm going to put my higher point on top, the one with the higher power. Now x is my power, so I'm going to use my point with the 6 in it. I'm going to do that. It's going to make my life a little bit easier as I'm going. So I know that y is 256. Equals, I don't know a, I don't know b, my power is going to be 6. Next I'm going to do this point over here, the original one out front with the lower power, and I know that y is 16. I don't know a, I don't know b, but I do know that x is 2. So now that I have that written out, I'm going to go ahead and divide. Remember, I want to eliminate a variable so I can get the other one. 256 divided by 16 leaves me with 16. A divided by a, it's 1, cancels out. And remember here, I'm going to do 6 minus 2. When I divide with exponents, same base, I'm dividing the exponents, or I'm dividing the whole term, I should say. I'm going to subtract my exponents. So 6 minus 2 is going to be b to the power of 4. Now for this one, I'm looking at what number times itself 4 times equals 16. So for this one, I know that 2 times 2 times 2 times 2 equals 16. Therefore, b is going to equal 2. So I've got my first part. Now I need to go back and find a. And remember, it's easier to use the smaller point. So I'm going to use the smaller point, and I'm going to plug in b as well. So I know that x is 2. I know that y is 16. And I just solved, we're going to use that, we worked so hard to find it, b is 2. And I'm going to plug in everything I know to my y equals ab to the power of x equation. So y is 16. A we don't know, that's what we're going to solve for. B is 2. And x is also 2. 2 squared is 4. So I have 16 equals a times 4. And then I divide. 16 divided by 4 leaves me with 4 for a. That's going to be my y-intercept if I were to graph this one. So I have a y-intercept. and I have my factor. And I'm going to write those out in equation form. Y equals 4 for my y-intercept, that's my a, times 2, my factor, to the power of x. And if you wanted to write it like this, you can do that as well. They mean the same thing. Okay, guys, now that one on the top left under the word example, this one right here, I'm just going to tell you, you can pause the video, try it on your own. If you need help with it, message me if you're not getting the same equation. The equation that I am getting for that one is y equals 3/2 for a, b is 2 to the power of x. That's what I'm getting there. So if you're not getting that when you try it on your own, make sure you message me so we can figure it out together. All right, next, we're going to be writing an equation from a graph. So excuse my sketched out graphs here. I tried the best I could. You have nice ones on your sheet so you can see them well. For this one, I have a graph. I have 2 points that are given to me. And notice that those 2 points, guys, you could automatically, like if you forget how to do this, if you were in the middle of like a test or at home and you're doing this Google form and you forget how to do the process for finding it from a graph, you can always just do it as if you have the 2 points like we just did before this. But for this one, I'm realizing that it gives me the y-intercept. When I had 2 points, like the 3 that we just did up above, I had to solve for the y-intercept. Here I already know it. I already know that a is 1/2. So save yourself some work. I'm just going to write a equals 1/2. And then for me, there's a few different ways to go about this. My favorite way, which I'm going to show you, is just to use the other point. So I know a is 1/2. I'm going to use this other point here to solve for b, to figure out my rate. So I know a is 1/2. I have an x of 1 and a y of 1. So I'm just going to plug that into my equation. So 1 equals, I know a is 1/2. That's my y-intercept. I don't know b. That's what I'm trying to figure out. And I know that x is 1 as well. So when I do this out, what I'm doing here to get b is I'm going to, I have to divide by 1/2, which is the same as multiplying by 2. Which is the same as multiplying by 2. So you can think about it in either way. I'm going to multiply by 2 over here. So 2 is going to equal b. So now I have 1/2 for a. I have 2 for b. Therefore, my final equation is going to be y equals 1/2 times 2 to the power of x. And I have one more over here. Notice this one's going downhill, right? I shouldn't say downhill. It's not a perfect downhill like it is when it's linear, but we are below the x-axis. So I'm going to go ahead and find my y-intercept right away. That's the easy part. I know that a is going to be -4. And I know that because my y-intercept is 0, -4. Now I need to go back and find b. I'm going to do so by using that other point that they provide me with. And I'm going to plug it into my equation. So I know my exponential function equation is y equals a times b to the power of x. So I'm going to plug in what I know now. I know that y is -8. I know that a is -4. That's my y-intercept. B, I don't know. That's what I want to find. And I know that x is 1 from the point that they gave me. So x is 1. I'm just going to go ahead and divide by -4. -8 divided by -4 leaves me with 2. So 2 equals b. I have y equals -4 times 2 to the power of x. And you would be done there. So last but not least, a little more graphing, but we're going to switch it up and do it in the opposite way. I'm going to give you the equation now, and you need to graph it. And a few things about graphing when you're in algebra in 8th grade. We only require you to have 2 points on your graph, the y-intercept and one other point. You need arrows on the end of your on the end of either side of your graph, unless we're talking about a specific real-life scenario where you wouldn't do that, but we're not going to worry about that for now. So we're going to have arrows on both ends. We're going to have 2 points. And the other thing, we learned a word in Monday's video, asymptote. That's that line in an exponential function where it gets super, super close to the x-axis, but it never touches. So you need to make it very clear that that x is not touching, or sorry, that your function is not touching the x-axis. So those are the 3 requirements, and we will just get started now. We're going to kind of just go through and choose an x value. And if this were me, you know what, first we're going to do the y-intercept. Sorry, jumping ahead of myself. So it tells me my a is 3, therefore I know that I can put a point on 3 right away. So 0, 3, I'm going to mark that. Next, I need to find another point to mark because I need 2 of them. I've got my y-intercept, I need to pick another one. Now, most of the time, most kids would just start with 1 for x. It's easy, right? So let's see what happens there with that one. I'm going to plug in 1 for x. So if x is 1, what is y going to be, is what we're looking at right now. So 3 times 4 to the power of 1. Well, 4 to the power of 1 is just 4, and 4 times 3 is 12. So that works. That point's great. It does not fit on our graph here, though. So sometimes on your homework, you all put a point way up here and be like, yeah, it works. You really want to make sure it fits in your graph. So I just wanted to show you if you had a graph that this point wouldn't fit on, we're going to need to use a smaller exponent here. So let's just try a half and see if that's going to work. If I plug in a half for x, that means it looks like this. Y equals 3 times 4 to the power of a half. Well, remember when we were doing exponents back when we were in school, power of a half means the square root. So the square root of 4 is 2, and 3 times 2 is 6. So that means I have the point a half 6 as well. So I can graph that. I'm going to go over a half and up 6. I'm going to put a point. And I'm going to go down, 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 down. This asymptote can never touch the x-axis. We're going to do arrows, and that's about what the graph should look like. I know it's on a shower wall, and it's a super rough sketch of it, but hopefully you get the idea. If you wanted to go back and label the points, 0, 3, and a half, 6, you could. Another thing that you could do if you wanted to make your graph even more detailed, you could say, well, what if I used -1? I lost my red marker. Oh, here we go. What if I plugged in -1 for x if you wanted to make sure you were in the right direction? So if you plugged in -1, it would look like y equals 3 times 4 to the power of -1. Now remember, negative exponent, I'll just plug in another little review tip here. -1 exponent means I'm going to find the reciprocal. So I have 3 times 1/4. So my y value here is just going to be 3/4. So that means that I also have the point -1, 3/4 that I can put on my graph. So -1, 3/4. So I'm a little off there. Forgive me. Be easy on me there. All right, let's move on to the next one. Notice how this one, guys, my factor is 4. It's more than 1, so it's a growth graph here. Right here, hopefully you could realize I know my y-intercept, my growth is a half, so I'm going to have a decay graph for this one. So this one's going to be going down instead of up, decaying instead of growing. So for this one, right off the bat, I know that 2 is going to be my y-intercept. So I can go ahead and plot that. And the next thing I'm going to do, I'm going to make it easy on myself. I'm just going to use x as 1. You can choose what you want, but don't make it hard on yourself. Just start with x as 1. Now when I plug in 1, I have y equals 2 times a half to the power of 1. Well, anything to the power of 1 is itself. So 2 times a half is just 1. So I have the point 1, 1 on my graph. It is going down, which is good because we noticed it was going to be decay before we even started. And if you wanted to have more points on there to make your graph more accurate, you could try a 2. Let's try plugging a 2 in. So if I plugged in 2, we're going to have lots of 2's in this one. Y equals 2 times a half to the power of 2. Well, a half to the power of 2 means 1/2 times 1/2. Write that out for you guys. 1/2 times 1/2, which is 1/4. So I have 2 times 1/4. And if you multiply across, you end up with 2/4, which is just a half. So I have another point that I can plot on my graph. to a half, and I am still going down, which is a great sign. I'm showing decay. You can draw your graph. You could plug in a -1 for x if you wanted that extra point in there. You only need 2 of them, but being as accurate as you can is always good. That asymptote never touches the x-axis here. We're just going to draw an arrow. And that would be that graph. I know it's really rough. Make sure that your graph on your notes, if you're taking them at home, make sure it shows the point 0, 2. I'll add that in there. 0, 2, your y-intercept. Make sure it shows 1, 1, and 2, 1/2, and you should be good to go. Last but not least, I have one more for you, and I wanted to show you this one for a specific reason. This one came up on the Google form from Tuesday, and I had a few questions on it, so I wanted to make sure to clarify. So this one doesn't really show the separation of the y-intercept and the factor. So before you even started at all, I just want to show you what happens and why I know what I'm about to tell you guys. If I made my table out and I said x versus y, let's just say I plugged in a 0 for x. If I do y equals -4 to the power of 0, well, we learned when we were looking at exponents, anything to the power of 0 is just 1, right? And this 0 is just touching that 4. It's not touching that negative. It's just touching the 4 because there's no parentheses. So here I would just have left over a -1. So this tells me that my y-intercept, when x is 0, y is -1. This tells me that my y-intercept is going to be y equals -1 times 4 to the power of x. So that's why I can kind of separate it out like that. This equation here and this one that you have originally are the same thing. And that's how I know that my y-intercept is going to be -1. So I'm going to put a point there to begin. And the next thing I'm going to do is just, like I said, be easy on yourself. Always try 1 first. See if it's going to work for you. Let's plug in a 1. If I plug in a 1, it looks like y equals -4 to the power of 1. Well, 4 to the power of 1 is 4. So I'd be left with -4 here. I can fit one -4 in my graph, no problem. 1, 2, 3, 4. I'm going to put a point. And I'm going to draw my asymptote. It's not going to touch. It's going to get super close, but it doesn't touch. And this is about what it should look like. Now, if you wanted to be more detailed, plug in more numbers. You can definitely do a 2. If you plug in 2 for x, you're going to have -16. So it's going to be way down there. Plugging in a 1/2 would work as well here. That might be helpful for you. If you did a 1/2, you'll get another number that's easy to work with. It'll be up here. Let's just do that quick. If you plugged in a 1/2 for x, if you wanted another point on there, well, y equals -1 times 4 to the 1/2 power. Well, 4 to the power of a 1/2 is going to be just 2. And -1 times 2 is -2. So that's making sense there. It's going to fall in right about there. 0.5 -2. So put as many points as you want, but I just want to be clear again, guys, don't stress over it. I would be happy with the y-intercept, 1 additional point, and you showing me that the asymptote gets super close to the x-axis, but never touches it. So I want you guys to reach out with email or a remind message. We can set up a Zoom if you need help. The next one that you guys will have will be Thursday at 10:45. And that code will come out through your school email. I hope to see you all there, and message me beforehand if you have any questions that I can help with now. I'll see you guys soon. Bye-bye.